Hello everyone, today our topic is organic interconversion with the help of Grignard reagent. Conversion tip: any of the conversion in which you have to convert one of the carbonyl into another one, that is from lesser carbon content to more carbon content, or you are converting carbonyl to alcohol, alcohol to carbonyl, or a alcohol lower member to a higher one. In all these conversions we do with the help of a Grignard reagent. In last three conversions, along with the Grignard reagent, one more reagent we use here, that is a copper at 573 Kelvin. This copper at 573 Kelvin is used for dehydrogenation of alcohol. Let's understand what is dehydrogenation. Dehydrogenation is basically D means removal of what? Removal of hydrogen. So the removal of hydrogen is known as a dehydrogenation reaction. Let's take a simple example here. I am taking primary alcohol CH2OH. So this primary alcohol with copper at 573 Kelvin undergo dehydrogenation reaction where hydrogens are removed. One of the hydrogen is removed from oxygen and the second one is removed from a carbon adjacent to oxygen. This result in the formation of carbonyl compound. Let's take an example here. I am taking simplest example of ethanol, CH3CH2OH, ethanol with copper at 573 Kelvin undergo dehydrogenation reaction where hydrogen from oxygen and the other hydrogen from carbon, which is next to oxygen, are removed, and this result in the formation of CH3CHO. For better understanding, we can also write it like CHHOH. So these two hydrogens are removed. Primary alcoholic group functionality CH2OH. We can also write it like CHHOH in order to show how the dehydrogenation takes place. So this part undergo dehydrogenation in presence of copper at 573 Kelvin. In place of copper at 573 Kelvin, you can also use silver at 573 Kelvin here. So how the dehydrogenation takes place? These two hydrogens are removed. Hydrogen of oxygen and the hydrogen of carbon, which is next to oxygen. So this result in the formation of CHO. So primary alcoholic group on dehydrogenation results in the formation of aldehyde. Let's take an example of secondary alcoholic group. Secondary alcoholic group functionality is CHOH. We can also write it like this way. So copper at 573 Kelvin, this part undergo dehydrogenation, removal of hydrogen, which result in the formation of ketone here. So in a nutshell, we can say that primary alcohol on dehydrogenation, they produce aldehyde, whereas secondary alcoholic group on dehydrogenation produces ketone. For better understanding of dehydrogenation, let's take few more examples. Here I am taking CH3OH. This CH3OH on dehydrogenation reaction, which is taking place in the presence of copper at 573 Kelvin, resulting in a loss of hydrogen and produces CH2O. CH2O is a methanol part. Next, I'm taking here CH3CH2OH undergo dehydrogenation reaction as it is a primary alcohol, so this also results in the formation of aldehyde. Now let's switch to secondary alcohol. CH3, CHOH, CH3. This one is isopropyl alcohol, or you can also call it a secondary sec-propyl alcohol. So this sec-propyl alcohol in the presence of copper at 573 Kelvin result in dehydrogenation, that is the loss of these hydrogens, and finally it forms ketone as a major product here. Let's take one more example for better understanding. Benzyl alcohol I am taking here, CH2OH. So this benzyl alcohol on dehydrogenation in presence of copper at 573 Kelvin results in loss of hydrogen, and the leftover part here is a CHO over a benzene ring, that is a benzaldehyde. So let's discuss a series of reaction in where we are using a Grignard as well as copper at 573 Kelvin. So the first I have taken here alcohol. Alcohol changes into carbonyl. So the step is copper at 573 Kelvin, that is a dehydrogenation. Then the carbonyl, it changes into the alcohol part. So it means here I have used Grignard reagent followed by hydrolysis. And last alcohol, that one is changes into the carbonyl part. Again I have used here copper at 573 Kelvin. Let's understand this part with the help of a simple example here. We take CH3OH, methanol, simplest alcohol. So this methanol at copper with copper at 573 Kelvin, on dehydrogenation it changes to HCHO part, carbonyl part. This carbonyl with Grignard I am taking here CH3MgBr. On hydrolysis, it gives CH3CH2OH, primary alcohol. This primary alcohol with copper at 573 Kelvin, it changes into CH3CHO, aldehyde part. So the conversions here are methanol, that one is converted into ethanol part, or you can say, you can frame a question like this way, okay, convert methanol into ethanol, this last product, ethanol, it is also known as acetaldehyde. Or we can frame a question like convert, we start from this part only, convert methanol, which is also known as a formaldehyde. Formaldehyde is a common name for methanol. Convert methanol into ethanol, or we can frame like convert formaldehyde into ethanol. So whatever the conversion is, I earlier told you, okay, whatever the conversion is, whether you have to convert carbonyl into carbonyl, carbonyl to alcohol, or alcohol to carbonyl, or a lower member of alcohol series to a higher member of alcohol series, then we always do all such kind of conversions with the help of Grignard along with dehydrogenation reaction. For better understanding, let's take one more example. CH3CH2OH I am taking here, ethanol. So this ethanol on dehydrogenation, as it is a primary alcohol, it changes into a aldehyde part, CH3CHO. Aldehyde on addition reaction with Grignard. Grignard I am taking here C2H5 MgBr, methyl magnesium bromide, followed by hydrolysis. So the resulting product here is CH3, CHOH, C2H5. So I'm writing C2H5 as CH2, CH3 here. This product, again I'm doing copper at 573 Kelvin dehydrogenation reaction. It forms CH3, C double bond O, CH2, CH3, which is butanone. So the transformation here are, first one, ethanol, that one is converted into butane to ol. Second conversion we can frame from here. Convert ethanol into butanone. Or we can frame it like, start from this part only. Convert ethanol, its common name is acetaldehyde. So convert acetaldehyde into butane to ol. And last, convert ethanol into butanone. Let's take one more example of primary alcoholic group with benzene ring. So benzyl alcohol, this benzyl alcohol on dehydrogenation reaction, it changes into benzaldehyde. Benzene ring having CHO group over it. This benzene ring with methyl magnesium bromide as a Grignard reagent, and on hydrolysis it gives alcohol, and this alcohol so formed on dehydrogenation reaction, it gives COCH3. So the type of conversion, first is convert benzyl alcohol into acetophenone. This one is acetophenone. Or we can frame second, convert, start from this part, benzaldehyde into acetophenone. Now let's take an example of secondary alcohol. Secondary alcohol, they form ketone on dehydrogenation reaction. So let's take isopropyl alcohol or sec-propyl alcohol. So this isopropyl alcohol on dehydrogenation reaction, it forms acetone. This acetone on reaction with CH3 MgBr methyl magnesium bromide and hydrolysis, it gives tert butyl alcohol. Now in case of tert butyl alcohol, this tertiary carbon, it doesn't have any hydrogen here. So in this case, we are not able to do dehydrogenation reaction because of the absence of hydrogen over here. So the important conversions, first is you have to convert isopropyl alcohol into acetone, or we can frame a conversion like convert sec-propyl alcohol, sec both are same in case of word root prop. So sec-propyl alcohol into tert butyl alcohol, or we can frame a conversion here. Convert acetone, which is propanone, into tert butyl alcohol.